Hello everyone, in today's video lecture we are going to see what is K-means clustering algorithm. So before we start with in detail explanation of this K-means clustering algorithm, we will discuss about some real life analogy. Now what is this analogy? First one, if you go to any of the coffee shop, you might see there are some people who are sitting on table T1, T2, T3, T4, right? So there might be 2, 3, 4, 5 people sitting on these tables respectively. Now what are these? These are nothing but the clusters. What are these? These the people sitting on particular table. They are having some common interest. They are sharing some common interest. They are connected to each other. Whereas the people sitting on the T2 table, they are not connected to the people sitting on the T1. They are not sharing the same interest, right? So these are what? These are the examples of the clusters. Now when you visit any shopping malls, you might have seen the separate items. Separate items are stored in separate counters, so they are not mixed together, right? So this is also one of the analogy of the clustering. So what is clustering? Clustering is nothing but a process of dividing data sets into separate groups, which in turn consist of the similar data set. Now let's have a look at the real life examples. Have you ever wondered why Amazon gives you the suggested list of the recommendations? It works on the recommendation system, right? There are some algorithms which are running at the back end, which keep track of your watching history, your viewing history, right? Similar to the Flipkart. Flipkart also tells you that this just purchase this product. This might be the list. You may like this item. Similarly, Spotify suggests you the list of the songs which you might be interested in. Netflix suggests you the list of the movies. Bank also suggests you some kind of loans to be taken. Car loan, if you are searching for a car on Google or you are inquiring about it, so it also recommends you about the car loan or the some kind of policies or investments to be done, right? So these people know, how these business tycoons, they understand what are your interest are. So that is based on your watch history, your movie, earlier the movies which you have watched, your viewing history. They keep track of everything and they just collect this data set, and they just based on that there are some algorithms which are running on the back end, and they just give the suggestions for you. You may like this, you may go ahead with this. So what are the similar applications? First one is the data clustering. Data clustering is what? It is nothing but a grouping together similar kind of web pages. Whenever you search on something on a net, right? So you get some information. So information retrievals, it is information retrieval. Similarly, in retail businesses, based on the customer's interest, based on the customer's buying pattern, their buying behavior pattern, they understand that this product, if we try to sell it, we will be making profits. So similar to that recommendation system like Amazon and Flipkart, just now we have discussed. Insurance company, they try to make some kind of customer segmentations based on the policies they may like, based on the customer's age, data, their personal information, their annual salary, the what locations they are staying in. So they just try to collect everything. So they are this way they are trying to make the customer retention efforts. Now what about the businesses? Business also do the market segmentations, sales campaign. They are given some sales target to achieve, that you have to cross this much target. So for that they again do the market survey, in which particular, in rural area, this product may be the beneficial for the people, so they may try to sell that product in that area. So it is depends on the area, the customer's interest, their past purchasing history, their behavior pattern. So all these things are getting analyzed somewhere. Whereas a social networking site like Facebook and all, they just try to collect your all the personal information. Banks try to analyze the profitability. Banks run on the loans. They try to offer various loans to the customers. Credit scoring. They try to accumulate this kind of information. So even document clustering is based on the tags and keywords. They just documents are clustered separately. Now, what are the type of the clustering? There are two types, male and female. Okay, so there are two types in the sense, central as well as hierarchical clustering. Now, when we talk about the central, so just take the example, male is one cluster and female is another cluster. They are independent of each other, right? So here central, they are not dependent on each other. So male and female are falls under the category of central, whereas hierarchical clustering means what? Suppose if you go to any kind of suppose you take the example of Amazon. Amazon is having the warehouse, so it has collected the different items together. So maybe the items, maybe the on the type, and what are the subtype? Household items, furniture items, then electronic goods. Below that electronic goods, there might be mobiles, laptops, TV, LED, everything. So these are the different clustering types. Now let's move ahead with the K-means clustering. What is this? K-means is nothing but popular unsupervised algorithm. What do you mean by the unsupervised algorithm? Unsupervised means we are not going to assign any labels prior to it. We are just playing with the data. We are getting the data. We are just plotting it, and then trying to, when we plot the data, we come to know that this particular cluster belongs to one. This data set is belonging to one particular cluster. Another data set is belonging to another cluster. Likewise. So what, we are just playing with the data, we just try to plot, we just try to understand, analyze the data, and after that we come to know, oh, these data points are belonging to this cluster. Another data point is belonging to another cluster. Likewise. So it is popular unsupervised algorithm. As you can see in the figure. So in the first figure, it is k is equal to 1. K is equal to 1 means what? All the clusters are belonging to one cluster. K denotes the number of clusters based on the features. K is equal to 2 means what? There are two clusters. Okay, so here you can see there are separate centroids. K is equal to 3. There are 3 clusters and 3 centroids are there. So it is popular unsupervised algorithm. Now how centroids are calculated? Based on the data points, we keep on calculating their means. So main goal is to group the similar data points into a cluster because of certain similarity. The one cluster may be different from another cluster. So let's see the algorithm part. So we will be choosing random random points as cluster centroids. We will choose some input k number of clusters. So we will choose some random points as cluster centroids. So for each xi means what? For each data point, we will find nearest centroid, means we will try to see the distance between the data points, right? So we will try to see, suppose if in this red cluster another data point is being added, we will try to calculate the distance between that centroid and that data point, right? Newly added data point. If it is lesser than other centroids, that point will be added to red cluster. Right, so find nearest centroid Cj. We will try to analyze the distance between that data point and cluster centroid. Then assign, if it is lesser, then assign that data point to that particular cluster J. Now for each cluster J, from the data points 1 to k, we will be trying to calculating the mean. Mean means the centroid. How to calculate the mean? We will be taking the sum of all these data points divided by the total number of data points. So this will be the cluster centroid. So we keep on trying to update this mean or the centroid iteratively each and every time the new data points are getting added to that particular cluster. So we keep on calculating the Euclidean distance. Euclidean distance means what? It is sum of squared errors between these distance, right? Then group these data points together into the clusters. So we will group this based on the Euclidean distance. If they are having the minimum Euclidean distance from the centroid, then that data point is considered to be the part of that particular cluster. So when we will stop this, now this process is going to be iteratively followed. Each and every time the data point is added, the centroid is calculated. Okay, so when we will be stopping this, when there are no more clusters to be formed, no more data points to be considered, that time we will stop. So what is this Euclidean distance? It is nothing but a distance between p comma q similar to distance between q comma p. What we do, we just try to calculate the distance squared summation of all these data points distance square. Why square? Because there might be some negative distances also, right? Negative distance means pi minus 4 or 4 minus 5. 4 minus 5 then minus 1. Minus 1 square, right? So it will become 1. And likewise the summation of all these data points. So it is square root of summation of square of these distances. Okay. So what are the limitations of this? There is no guarantee as such. See here we are choosing the number of clusters on our own. Like we are saying that we will choose k is equal to 2, k is equal to 3. So what about, there might be some chances that if we would have gone for 4 to 5 clusters, then we would have got the accurate results. So it does not guarantee to find the optimal solution. Okay, in this case, when we are choosing that k number of clusters is specified by the user is telling, okay, let's assume k is equal to 2. But if we would have taken k is equal to 3 or 4, the result would have been better, right? So if k is equal to 2, only 2 clusters. So it may be possible that actual clusters may be 3 or 4. So it would have made more sense. So how to do what? So what is the remedy for this? How to avoid this limitation? How to overcome this limitation? Based on, we will try to calculate the optimal value for total number of clusters. How to calculate this total number of clusters k? That we are going to discuss in our next video lecture. What we are going to do here? So before that, I would like to tell you the overview of this. So this is called as elbow point. What is this elbow point? When we try to plot the sum of squared errors and the number of clusters, you can see here between 4 and 6 the 5, right? 5 is nothing but a turning point. Why this is turning point? Why? Because after that you can see below that the sum of squared error is diminishing. Sum of squared error is diminishing. That means 5 should be the number of clusters to be taken. So what should be the optimal value for the total number of clusters? In this case 5, right? So this we are going to see in our next video lecture. We are going to plot this k-means clustering using scikit-learn. Okay, so please stay tuned to my channel. If you have not subscribed, please subscribe to my channel. If it gives me the motivation to upload some more interesting video lectures and help out all my students, so please subscribe to the channel, and thanks for the watching.